This question is about relationship between the graph of function and first and second derivative of that function. Let f of x be some function such that all its higher order derivatives exist. In the picture graph of f of x, f prime of x, and f double prime of x are shown over some interval. Basically, we want to find which one is the function, which one is the first derivative, and which one is the second derivative. By looking at the graph of the function and focusing on this point, we know b is not original function, because at this point, derivative of the function is 0, and neither a nor c is 0. So b cannot be the original function. So either a or c are original functions. Let's pick one of them randomly. Let's assume c is original function. If c is original function, then either b or a are the first function. In this case, at this point, the function is maximum, the tangent line is horizontal. If c is the original function, then b is the derivative. So at these 2 points, derivative is 0. Before this point, function is increasing, derivative is positive. After negative, so by looking at the graph of c and b, you see c is the original function, b is derivative, therefore a is second derivative. So in this type of questions, what do? You check the derivative at these 2 points are 0. Before this point, the derivative is positive. After it is negative, again positive, and the graph of derivative should be above the x-axis here, above the x-axis here, and below between. Next question is an implicit function is given, and we are looking for the points on the graph of the function implicitly defined, and we want to find the points at which the slope of tangent line is 1, because 2 parallel lines have the same slope. We find the derivative of the given function. Obviously, function is given implicitly. The derivative of 2x plus 1y plus xy prime plus 2yy prime equals 0. Factor y prime isolated, you have this function as the derivative. Derivative equals to 1. Do cross multiplication, you have this equation. This means y equals negative 3x. So at that point, basically x2 plus x, or points, is 4, and y equals negative 3x. Therefore, we have to solve this system of equation. We use substitution method. If you substitute equation number 2 into 1, you have basically 7x2 equals 4, meaning x equals plus minus 2 over root 7, and y is 3 times minus 3 times x minus 6 over root 7. Meaning at these points, positive root 2 over 7 and negative 6 root 7, or negative 2 over root 7 and 6 over root 7, the tangent line is horizontal. Next question is related to Related to the rates question, a hot balloon is moving up at a given rate. We are looking for the rate at which the height is changing at given point. A hot air balloon rising straight up from a level field is tracked by a rangefinder 1500 meters from the liftoff point. At the moment that rangefinder's elevation is pi over 4. Pi over 4 means at this instant. When it is pi over 4, you deal with an isosceles triangle, therefore height is 1500. The rate of increasing of the angle is given, d theta d t is 0.2 radian per second per minute. How fast is the balloon raising? We are looking for dx dt at this point. This is the relationship between x and theta. Tan of theta is x over 1500, meaning x is 1500 tan of theta. Dx dt is 1500 secant squared of theta d theta dt. Now we are looking for dx dt at theta equals pi over 4. Secant of pi over 4 is root 2, so you have 2 and 0.2. You do the calculation here, meters per second per minute is the answer. Last question is a curve sketching question. What we want to do, we want to sketch the graph of a given function. It's a rational function. And first and second derivative are given in the question. Okay. Part A, we asked to find the domain of function. Obviously, domain is all real numbers except 3. Part B, x-intercept. X-intercept, you set the numerator of the original fraction to 0. You find negative 1 and 0 as x-intercept. If you plug y to 0, you get 0 and 1 over 9 as y-intercept. Part C, talking about the vertical and horizontal asymptotes. X equals 3 is the vertical asymptote of the function because denominator is 0 at x equals 3. The degree of numerator is less than the denominator, so y equals 0 is horizontal asymptote. Part D and E are talking about interval of increase, decrease, and maximum, minimum. Interval of increase, decrease, and local maximum, minimum, you have to draw the sign chart for first derivative. At negative 5 and 3, derivative is 0 and undefined. If you plug in a number more than 3, you see derivative is negative. Then between negative 5 and 3, it is positive. By plugging 0, you can find out it is positive. Any number less than negative 5, if you plug in into the derivative, you get a negative number. Therefore, function is decreasing and increasing and decreasing. Negative 5 is the x-coordinate of the local minimum. If you plug in negative 5 into the equation, you have negative 5 plus 1 divided by 64. If you reduce the fraction, you get negative 1 over 16. Part F and G is related to point of inflection and concavity. You set the second derivative to 0, you get negative 9. At negative 9, second derivative is 0. At 3, it is undefined. If you find the sign of second derivative more than 3, it is positive. And less than 3, between negative 3 and 9, negative and negative. So concave down, and concave up. So the function is concave down before negative 9, concave up after 9. It should be fixed here. Now we put all this information together and sketch the graph of the function. X-axis, Y-axis, horizontal asymptote is y equals 0, vertical asymptote is x equals 3. -5 and -1/16, say this is -5 and -1/16 is local minimum. -9, and if you plug in -9 to the power of to the original function, you get -1/18. This is point of inflection. Let's assume it is -18. Then we can sketch the graph of the function now. Close to the asymptote starts, then minimum. When x is -1, you have the x-intercept, and y-intercept is 1/9. 1/9, and get close to the vertical asymptote. Concave down at the beginning, then concave up. And after asymptote, it is concave down again. Don't forget, the graph always starts from close to the horizontal asymptote, gets close to vertical asymptote, starts close from vertical asymptote, gets close to horizontal asymptote. Thank you.